Yes, students, we have finished oxygen in P block elements oxygen family. Now next is sulfur. Sulfur. So it has two allotropes. One is rhombic, that is orthorhombic. Yellow sulfur, and the other is rhombic. Let me write first again. Sulfur. To start sulfur, oxygen family. In the oxygen family, we finished oxygen, then sulfur. Sulfur, it has two allotropes. One is orthorhombic sulfur, and the other is monoclinic sulfur. The structure is very important here. The structure of orthorhombic, and it is S8. It is crown like a crown. So in the center there are two sulfur atoms. Then sideways you will draw like this, sulfur, sulfur, and then join it with another sulfur atom. Then same structure this side also, the other side, sulfur, sulfur, and join it. Here one more sulfur. In this way it is crown like. Whereas the monoclinic sulfur is, the form is chair form. So you get it from the rhombic or orthorhombic sulfur S8, and you get the chair form of the monoclinic sulfur SS joined together and draw like the chair form. This is the chair form. Okay. Now, which form of the sulfur shows paramagnetic behavior? Sulfur also exists in S2. This form shows paramagnetic behavior. Why? Because in vapor state it has two unpaired electrons. Two unpaired electrons in the antibonding pi orbital. Antibonding pi orbital. Okay. That's why it shows paramagnetic behavior S8. Next, let us see the reactions of sulfur. Reactions of sulfur. Sulfur, the oxidation state of sulfur is 0, so it reacts with sodium hydroxide and form Na2S and Na2S2O3. I am not writing the balance equation. You just see that in this sulfur is -2 and in this sulfur the oxidation state is +4. So it is reduced and this is what? Oxidized. So it is a disproportionation reaction. Okay. Then sulfur reacts with H2SO4 and form SO2, light yellow gas is evolved. Then it reacts with concentrated HNO3 and form NO2 gas plus H2SO4 plus H2O. It reacts with oxygen and forms sulfur dioxide and sulfur trioxide. So these are some of the reactions. Now SO2, out of this SO2 and SO3, which one is more acidic? Which has more oxidation state will be more acidic. And you can see that if you react it with water, it will form H2SO3. Whereas if you reacted this with H2O, then you will get H2SO4. And here also oxidation state is more, plus 6, and here oxidation state is plus 4. So as sulfur in this is having more oxidation, more the oxidation state, more will be the acidity. Now next, let us move to SO2. SO2, preparation of SO2. Sulfur can be prepared by directly reacting with, burn the sulfur with oxygen, heat it, you will get SO2. And if you use vanadium pentoxide, then you will get SO3. That is in the contact process, it is there. In lab, you react any sulfide with sulfuric acid or any acid, dilute sulfuric acid, you will get H2O plus SO2. Okay. Industry preparation, if you take iron sulfide, react it with oxygen, you will get Fe2O3 and SO2. Now let us see the properties of the SO2. SO2 properties: slightly yellow in color, highly soluble, yellow gas, slightly soluble in, highly soluble in water. Then it causes a burning sensation on skin. Burning sensation on skin. It reacts with water and form H2SO3, indicating that it is an acidic oxide. This is an acidic oxide. It acts as a reducing, you can say it as reducing gas, because it oxidizes. So it has the tendency of sulfur dioxide is in plus 4, it has the tendency to go into S plus 6 state. That's why it acts as a reducing agent and oxidizes itself. Okay, then what are the resonating the structure of this sulfur dioxide? You already studied sulfur dioxide. One will be the double bond and the other will be what? Single bond with 6 electrons or 3 pairs of lone pair of electrons here, 2 pair of lone pair of electrons with oxygen and 2 lone pairs over this. Then the resonance hybrid will be what? Just change the side of the oxygen. Here you will get with negative charge and here oxygen. That's all, it's very easy. Then the structure is what? Angular. Okay. So it acts as a reducing agent. So you will see the reactions of the SO2. Okay. Reactions of SO2. So it will act as this reducing agent. So SO2, it reacts with Cl2 and form SO2 Cl2, sulfuryl chloride. Then it reacts with O2 in presence of vanadium pentoxide, and we can convert it into the self SO3, then PbO2 and form PbSO4 white precipitate. So it acts as a reducing agent here. You can just check it. This chlorine is having how many here? 0. Oxidation state, it goes to -1. Okay. And sulfur S plus S6. So you can understand what is happening in the reactions. Okay. Then next is other reactions. Sulfur dioxide, it reacts with calcium hydroxide and form SCaSO3. Okay. It is milky in color, but if you take excess of SO2, then you get CaHSO3, which is not milky, but this is milky, whereas this is non-milky. Okay. Then it reacts with NaOH and form Na2SO3 and water. It reacts with KMnO4 in presence of water and forms sulfate plus H plus. Okay. Then if it reacts with K2Cr2O7, then Cr3 plus will be formed plus SO4 2 minus. Then if you take Fe2 plus, it will be converted to Fe3 plus. If you take PCl5, then you get PoCl3 plus SoCl2. This acts as a dehydrating agent. So these are some of the reactions. You have to just memorize it, है ना? Okay. Now let us move to the next compound, that is sulfur trioxide, SO3. First, the structure: sulfur angle is 120 degree, trigonal planar. So what will be the hybridization? sp2. Okay. Now oxo acids of sulfur. Oxo acids of sulfur. We have many acids. H2SO4, oil of vitriol also it is called. Then H2SO3 sulfurous. Then H2SO2 hypo. Then H2S2O5 thiosulfuric acid. Then H2SO5 Karos acid. H2S2O8 Marshall's acid. H2S2O7 oleum, and H2S2O6 dithyonic acid. These are some of the oxo acids of sulfur. Okay. Now next topic is how to prepare SO3, this H2SO4. Means the next compound that you are going to study is what? H2SO4, and the process of preparation is known as contact process. Okay. So there are 3 steps here. S plus O2 gives SO3. This is the first step. Then SO2 reacts with oxygen in presence of vanadium pentoxide and forms sulfur trioxide. Okay. Then third is absorption of this SO3 in H2SO4. It gives H2S2O7, which on dilution with water gives 2 moles of sulfuric acid. Okay. From the 1 mole you are getting 2 mole. So if you are thinking, then we are already using this H2SO4. So you can see that if you are taking 1 mole, you are getting 2 moles of sulfuric acid. Okay. So that was the preparation. Now let us see the properties of the sulfuric acid. Properties. Highly acidic in nature. You know that H2SO4 can release H plus very easily, and HSO4 minus. Okay. Or you can say, or it can again give this, or you can say it gives 2H plus and SO4 2 minus. So as it gives 2H plus, the N factor will be what? Equal to 2. So very strong acid, very strong. Here N factor will be 1, but here the N factor will be 2. And the K is very large for sulfuric acid. It behaves as a dehydrating agent. This question was asked this year. Example of dehydrating agent was asked. So the example is C12H22O11. If you take concentrated H2SO4, then it will give 12C plus 11H2O. So water, it removes water and the black carbon is formed. So it is an example of dehydrating agent. Remember it, very important. Okay. Then it acts as oxidizing agent also. Many reactions are there. How it acts as the oxidizing agent. It can react with active metals and release hydrogen gas. Okay. For example, 2Na plus H2SO4 gives Na2SO4 plus H2. This reaction you know. Now what are the reactions of the sulfuric acid with other elements or metals or non-metals? How it acts as a strong oxidizing agent. So with copper it forms copper sulfate. Okay. From 0 to plus 2 oxidation. Then with sulfur, sulfur dioxide and H2O. Sulfur is 0, it turns to plus 4 oxidation. Then with carbon, it forms carbon dioxide and SO2 and water. SO2 and water. Okay. Here also you can find out the how it acts as oxidizing. It reacts with phosphorus and forms phosphoric acid, SO2 plus H2. It reacts with dyed to form iodine plus SO2 plus H2O. Okay. So these are some of the reactions in which it shows that it acts as a oxidizing agent. Structure of sulfur, it is an oxo acid, so it will always have one double bond oxygen and one oxygen single bond. 3 oxygen is there. Okay, one more oxygen atom. It will be having double bond, one more, no? H. This will be the structure of sulfuric acid. We will see the structures of other oxo acids also. This is sulfuric acid. Okay. So 2OH is there, so that's why you can say it is a dibasic acid, है ना? Dibasic acid. It is tetrahedral structure. You can say that it is sp3 dehybridization is there in this structure. Now see one by one the other oxo acids also that I have told you before. Let us see one by one the structures of these oxo acids. First is H2SO3. Sulfur is in the structure with one double bond, so one oxygen atom with hydrogen atom in this and a lone pair of electrons. Okay. So it is also dibasic acid, can give 2H plus. Then next hyposulfurous acid. H2SO2. Hyposulfuric acid. H2SO2. So sulfur is attached to OH and OH only. So 2 oxygen and 2 hydrogen is finished. Now it has 2 lone pair of electrons like this. Okay, and here also it is having sp3 hybridization. Next comes H2SO5, Karos acid. In this peroxy bond is there, peroxy bond. So sulfur 2, in this way you already have in the sulfuric acid one oxygen, this peroxy bond is there. So this is the structure of Karos acid. Okay. Now some more structures. H2S2O8, Marshall's acid. Marshall's acid, it will also have peroxy bond. One side double bond O, double bond OH. Other side also double bond O, OH, double bond O, same. This side also. Okay, this is peroxy bond here. Next, H2S2O7, oleum. It is nothing but the fuming sulfuric acid. From this only you got 2 molecules of sulfuric acid, or it is also known as pyrosulfuric acid. So the structure is like this. There is no peroxy bond here. 2 molecules of sulfuric acid, you can just join it with one oxygen. OH, double bond O, then O, then double bond O, double bond O, OH. One more time I will draw this. H2S2O7. I think it was not clear, so I am drawing again. Double bond O, then one oxygen atom, sulfur, double bond O, then one OH here and one OH. This is oleum. And if you see if you want to arrange the decreasing order of these acids, you will see that the one which is having the most, means oxidation number as 6, will be the most strong acid. Then you will get H2SO4, then you will get H2SO3, and then H2SO2. Okay, this will be the, so we can say that higher the number of oxygen, higher is the delocalization, higher the resonance, higher the stability of this conjugate base. Here you are at plus 6, then plus 4, then plus 2. In both these you will see that oxygen here is more, so this will be first, then this will be second. Okay, so this finishes the sulfur also. We will start with the new family, that is the halogen family, in the next class.